Greetings. Welcome to the Evidence and Reasons for the Christian Faith video channel. I am so privileged to be joined by Dr. Howard Glicksman. He is the author of a book, Your Design Body. He's a co-author, and he's my inspiration. He was my inspiration when there's when I was just getting into the intelligent design movement in the early 2000s. At the time, my only contact with intelligent design was when Michael Behe came to visit our campus in, I think, 1998 to talk about his book, Campus at George Mason University, my undergrad alma mater. And he talked about his book, Darwin's Black Box. He has since, Dr. Behe has since had two other books. And that was my first introduction to intelligent design. And I had a crisis of faith and nearly left the Christian faith. And I said, well, all I have is my scientific training. Let me look at this thing about origin of life. And then I found this website. Let me share it with you. Let me put it on the screen here, called Access Research Network. And there was Philip Johnson, who was the pioneer of the wedge. And I would visit this website to get my weekly fix on intelligent design. And there was also a Dr. Howard Glicksman. And so this was my connection to intelligent design until I actually started to meet the larger community in person. I mean, all of this was just done remotely. Like I said, my only contact in person was just briefly with Dr. Michael B. He came to the campus and then gave his talk, and then he went back to Pennsylvania. So this was a big deal that some of this information was just, trickling in, but it was kind of like I was like a man in the desert, and like even a cup of cold water would sustain me. And so I just remember seeing Phil Johnson and Howard Glicksman giving their various updates, and that kind of kept me going. So here it is in 2026, really probably about over 20 years later, maybe 23. By the way, you still look as young as you did then in some of your photographs. Um, and so we had the privilege of having him here. I finally got to meet Dr. Glicksman in person. There are various private Discovery Institute events where we get to meet each other. The reason that they are private, I wish they could be public. There are some scholars and researchers who are in secular universities and research institutions, and it would not be um, in their career interest to have their name out there. And that's the main reason. Other than that, there are some people that are in the public sphere, like Dr. Glicksman, who can talk about their work. And so if you want to know what we talk about in some of these private meetings, you're going to hear some of it here. But like I said, a lot of times we have to make it private to protect the identities, especially of graduate students, of doctoral students, postdocs, etc., and young professors. So with that, Dr. Glicksman, thank you for joining us. And if you could tell us, I heard your journey. I think this is so compelling. Why don't you just start from the beginning, talk about how you became a doctor, how you got became a Christian, and just I'll please have at it.
Okay, yeah, well, thanks for having me, Sal. If I'm not mistaken, I thought we met at the Science and Faith the first time at the Science and Faith conference after we wrote the book, and
Yes.
you knew Steve, and of course we met since in that. So, I have to tell you, hearing what you just said, because I don't think I really knew this, but this is very gratifying because, I was writing all this stuff, and I'll get into how I got there, from back then. But I didn't know, here you are telling me you're reading all this stuff. And it was sort of very, it was early in my career, as I said, quote unquote career. If you look at those articles and the several series that I wrote on Access Research Network, you can see sort of the evolution of my writing, how we ended up with the book. But it all starts, I'm from Toronto, Canada. I grew up in a secular Jewish home. So God was never mentioned in my life, although I did have a bar mitzvah. I had no understanding of God. And so I remember when I was a junior, excuse me, a freshman, science freshman, I learned about Darwin. I remember the science teachers telling us about, how everything came from chemicals, basically chemical evolution. And I remember thinking to myself, well, I guess there's no God. Not that it really uh, had an effect on me that much because I wasn't following a specific religion anyway. And about 3 years later, I'm sitting in my senior biology class, and it was one of those days I think the teacher had to mark some tests or prepare for other stuff. He goes, "Oh, I'll read chapter 6 and chapter 7 of the book." And so I'm looking at the chapter 6 was about the eye. So I'm looking at all the different parts of the eye, and then I'm looking at all the parts of the ear, which was the next chapter. And in retrospect now, what must have been a moment of grace. Of course, I didn't realize at the time, this little thought came into my mind and said, there's no way this came from nothing. The quote unquote, the Darwinists are over extrapolating and oversimplifying things. There definitely is a supreme being. So I was about 17, 18 years old at the time. And I believed in a God. In retrospect, probably more of a deistic point of view. So I could just keep living my life the way it was. It wasn't for another 20 years that I really started to get serious about God and searched and became Christian. But in the meantime, went to medical school, got married a Christian, had kids. They were all brought up as Christian. And of course, when I went to medical school, I realized, I saw how easy it was to die. So I realized that just sort of cemented the idea that Darwinism, just didn't make sense at all. So I want to tell you the story about how I ended up writing for, if that's okay, Access Research Network. I want to tell you the other side of the story. So while you were searching, um, actually, it was funny. So this friend of mine, remember, I'm not following any faith, but he was an evangelical Christian. And I remember, and we've just got contact with each other. It's been years, and just recently through some of the stuff we've been doing through Discovery Institute, because I sent it to him. And anyway, we used to be in the doctor's lounge, where we dictated our notes or dictated just our summaries, and we would be there for an hour and a half because we'd start talking, then we'd start throwing Bible verses at each other. We'd be talking about the Lord for like an hour, etc. So one day he invited me to a talk on quote unquote intelligent design at the C.S. Lewis Center down in Clearwater, which is Tom Woodward. That he was running that there, and so I ended up going there, and it was Charles Thaxton who came. It was funny because I got delayed at something else, and I actually came an hour late. I thought I had missed it, and as I walked in, my friend says, "Hey, he just got here. His plane was delayed exactly an hour. Otherwise, I would have missed the whole talk." So it was Charles Thaxton, and of course, he had his book from 1984 there. It was it
Mystery of
was about
Life's
the big
Origin. Thaxton,
exactly
Ollie
history.
Olson. Oh my goodness. Yes.
Yeah. So he had I bought that and I bought Michael Behe's book, Darwin's Black Box. And I was enamored by the fact that um, scientists were, writing about this. So what had happened about a year or two before that was I had a neighbor who was my patient who asked me, she was doing a neighborhood bulletin, writing for the neighbors, and she once asked me, "Oh, it's Christmas and Thanksgiving that's coming up. Why don't you write a medical article in there? Tell people to watch what they're eating or something." So I ended up writing about preventive medicine, and basically it was more of spiritual, sort of saying we should be thankful for what God has given us in the body. So around that time, before I encountered Michael Behe and Charles Thaxton, I was already writing articles in my office for patients to explain how the body worked. Because as a GP, I'm a general practitioner. You see patients with high blood pressure, diabetes. They got lung problems, and so you're trying to explain. You got to get rid of the medicalese and not dumb it down, but just get it to a level that they can understand. And you're explaining how insulin works, and at the end, and they would be amazed at how complicated it was. And then we'd look at each other. I'd say, "Now you realize, of course, that science tells us this just came on its own, right?" And then we both laugh. So I'd already written all these articles, and so I knew I was able to write that way. So about in 2002, my older son, got married in Wichita, Kansas. And around that time, there had been some controversy, just like you had the Dover thing in 2005, but I think in 2001 or around that time, there was some controversy in the state of Kansas regarding teaching ID or just Darwinism. And so I was at my revisiting Wichita, and I was speaking to my son's new brother-in-law who was like a senior in high school, and we got talking about Darwin. How do they teach it in school? Because I was just sort of interested in what he was saying, and I was aware of ID for a year or two at this point. And then he says to me, and he commented that he had I think some relatives that were physical anthropologists. So and basically he says, they dig up bones and they look at that for human evolution, right? And so this little thought came into my head, and around that time I said, "You got to be kidding me! This is gross anatomy. We're looking at bones to try to decide how, evolution. I mean, we know how the body works at the molecular level. So, I thought to myself, this is like trying to figure out where a plane came from, where how the planes came from, by just looking at the fuselage, the wings, the cockpit, and the tail section, without considering modern metallurgy, electronics, jet propulsion, and aerodynamics. You know, so because when I look at bones, I realized that there were three or four things that immediately came to my mind. One was that there's basically three types of cells. Where does bone come from? There's three types of cells in the bone. There's one that lays down bone, there's one that resorbs it, and there's another one that supports it, with respect to remodeling of the bone. So you have to explain where you have to have all three cells for it to work, okay? And then the second thing I remember was I thought, well, the bones are the reservoir for calcium in your body. The calcium level in your bloodstream has to stay in a very narrow range, because if it goes too far in or outside it, too high or too low, you die from the nerves and muscles just don't work properly. So you have to control that, right? And the way you control that, the main control of calcium in the body is the parathyroid glands that are in the neck. There's four of them in each horn of the like you got the thyroid gland is like an H, and each horn of the H, a parathyroid gland, and the thyroid these glands have their cells have can sense calcium, and then if the calcium level goes down, it sends out more of a hormone called parathyroid hormone or parathormone, which goes to those cells in the bone and tells them to release the little calcium in the blood. It also affects the kidneys and the GI system to help build up the calcium. So you have this very tight control of calcium in the body. And then finally, in order for nerves and muscles to work properly, the calcium level in your blood has to be 10,000 times higher than in those cells, because sudden the calcium goes into those cells when it gets signaled, and it signals those cells to work, the nerve to send out its neurotransmitter, or the muscle to contract. So you need all these things. When I look at bones, that's what I see, right? And so I said, well, I got to start writing about this. I started, and I recognized everything else. How do you control blood pressure, sugar, etc. So that was the beginning. I started writing that. I actually ended up writing that, and somehow I got connected up with Art Batson, and I think his last name was Wagner. I don't remember his first name, but on the Access Research Network, Dennis Wagner, I think was his
Yeah,
name, right?
Dennis Wagner.
And so they were just kind enough to say, yeah, I remember. No, I think I contacted them because I wanted to write a book. And they said, well, we're not do with books, but if you ever want to do a web column, start saying stuff. So right around that time, a few years before that, about 10 years before that, I'd become Christian. And actually what happened was we were in a major car wreck a year or two before that. And um, I had, I guess I was following the faith, but wasn't really intensively doing it. No, not praying as much as I probably should, etc., and maybe not reading the Bible as much as I should. And so I was in this wreck, and I broke my back, and a lot of miraculous things happened. We should have, our car flipped, everything went out, but I was the only one that got injured. I went back to the doctor's lounge. I was back finally working, and I said to one of the doctors, because they're all saying, "What happened, Howard?" And I said, well, I guess I owe God big this time. And a little voice went off in my head, said, you've owed God big since day one. What have you been doing about it? And within a year or two of that, I gave up my practice, started doing hospice. I started writing about intelligent design, and I really got involved in my faith. So that's how that's where I how I got to where I was. That was the beginning in 2002. And it's 2003 is when I started writing the articles.
Well, this is wonderful. I'm gonna just to kind of give you a break, and I promised Howard. He wants me to call him Howard. It's hard for me to call him anything but Dr. Glicksman, but um, we mentioned some of the books, and I think let's see, I have a picture. I think this is. I don't know if this is the cover of your book. Let me try to bring it up. This is not the clearest. It says Your Design Body by Steve Loffman and Howard Glicksman. It is
Yeah.
available on Amazon and Discovery Institute Press. And let me see.
That's actually some of the videos that we did for promoting it. That's not the actual book, but
Oh, oh, okay. So this is great. So, um,
that was,
actually,
yeah.
you can Google around and look for the video, Your Design Body, and you can hear all the more details of this. We also talked about the book Mystery of Life's Origin. I have to say this is probably the most influential book. Let me just show a picture. You can get it at Amazon. There are various versions of this. I like the original one. There's been an updated one where you have James Tour and Brian Miller and other people adding, but the original one was just fabulous because you could actually see the level of thought. And so this was, as you said, very influential to you. This book actually has been viewed by some historians as co-founding the ID movement. The other book being so this was released in 1984. 1985 was the book Evolution Theory in Crisis by Michael Denton. So these are two great reads. That was the founding of the ID movement. And then we also mentioned Darwin's Black Box by Michael Behe, and that was also very significant. So, um, uh, so before I think before I stumbled on, around the time I stumbled on your work was when I was also reading um, Mystery of Life's Origin. And at the time, I had uh, three undergraduate degrees from George Mason uh, in the engineering disciplines, computer science, electrical engineering, with a minor in music, by the way. The way we kind of, Dr. Glicksman and I sort of got acquainted, he heard me playing piano at one of the Discovery Institute events. And Mrs. Glicksman also liked my playing. I was just like, I didn't think much of it, but I was so moved. And from that point on, we were kind of we were very well acquainted. Anyway, I had mathematics with a minor in physics. And so that's all I had to go on. I said, I don't know that there's a God, but this is all I know. This is all my training. I, I was unsatisfied with what was going on. When I go to church and it's like, well, you could try to be a little bit more persuasive that there is a God. And so when I looked at the mystery of life's origin, I looked at the complexity. I said the organization of this, even at the cellular level, much less the organismal level, which is the level that you work on. Um, I'm like, yeah, this doesn't happen. And then that was the beginning of my journey. So I went from being an aerospace, a scientist and air and engineer in the aerospace and defense industry. That's how I migrated into the biological sciences because as you said, you got that feeling. I got that feeling. I owe God big time. I owe
Can I
God.
just make, I just want to make a point for your audience that the big thing for me was in Michael Behe's book, Darwin's Black Box. It wasn't the black bacteria flagellum because, it's important, but that's not my bag, type of thing. But the most important part for me, which I really identified with because I already knew this ahead of time going in, I was interested to see how he was going to handle it. And that's the clotting cascade, coagulation cascade. So, most people don't know this, but there's about 10 or 12 different clotting factors that are made in the liver, that you have to have all of them. If any one of them is missing, you have hemophilia. Even not if it's just missing, if it's just a low level of activity, okay? But what most people don't know, and I think he does have it in the book, is you also have anti-clotting factors, okay? So you've got this balance going on all the time. And so, we know in medicine there's what's called hemophilia, and there's also hypercoagulable state. So your body at any given moment is at risk of either, dying from a spontaneous hemorrhage, like a GI bleed or bleeding in the brain if you don't have any clotting factors or you're missing one or two of them. And that goes for platelets as well in the blood. Or on the other side, you're clotting off, all the veins in your leg that go to your lungs and you get pulmonary emboli or clotting off the arteries or getting a stroke, arteries to it's unusual to get a heart attack from it, but you could. But that's the other extreme. So these are going on all the time. And usually when people have a hypercoagulable state where they're prone to clotting, it's just one little factor that's just off a little bit. Okay. Or on the other side, they're tending to bleed. It's just one little thing, but all these things have to be there. So immediately it's obvious that, gradual Darwinism, this gradualism doesn't make sense in any way. So I mean, that's what drove, that's when I saw what he'd written there. Then, I started writing in a similar fashion, but actually talking about how control mechanisms. You're an engineer, so, to control the water in your body, you have to have a sensor that detects the water, then it sends out a message to a hormone that sends out a hormone that tells you to drink. It goes to the thirst center and then also tells your kidneys to hold on to water, etc. So that's what started me writing that way. And it's great that and I appreciate hearing your story about how you came from that engine, 3 degrees, and then coming over to biology, but using that brilliance that God gave you, but now you're focusing on biology rather than uh, technology, basically. But it's sort of biological technology, right? Yeah.
So what happened to me, um, I well, my father passed away, and it weighed on my heart to take care of my mother. Um, I mean, some people are able to maintain a job and then, take care of their ailing parents. And I just lost interest in, I mean, aviation was everything to me, but uh, when I started to see God's designs, I said that my my whole life turned around. And so I was able to take care of my mother, and miraculously, I met John Sanford, who is a famous genetic engineer, Cornell research professor. His invention is in the Smithsonian National Museum of American History. And I approached him, and I volunteered to work. He said, "No, I'm going to pay you." I'm like, "Okay." I said, "I don't know anything about biology. I have no formal training in this." He said, "You have the right skill set, though. You're an engineer. I want that." Like, okay. So what had happened is I realized, oh my goodness, when what, I mean, the engineers that are now transitioning to study biology, they're like, wow, the way biological systems are organized is beyond anything we've ever built. Um, Superficially, it's easy to criticize, but there's been a recent book by Stuart Burgess, Ultimate Engineering, and in the last like 20 years, it's come to the forefront because of the biophysicists. They said, well, life is more perfect than we imagined. This is by secular physicists who are committed to, many of them committed to evolution, and they think evolution has made these devices. So it's not like they're coming from a religious perspective, but they said, okay, what are the limits of physics of what we can build in terms of sort of devices, like, how well can we build a navigation device? How energy efficient can we make something? How sensitive can we make some of the abilities to sense, like, hearing, sight, etc., or magnetic fields with creatures can sense magnetic fields. They said, well, and electric fields. Sharks can detect electric fields. Being an electrical engineer, it's like, okay, I talked to these guys. I said, how sensitive can we make this? And I said, look how sensitive a shark. It can measure nanovolts per meter. They said, I think that's about the limit of physics. And the physicists would actually work on these problems, and they're like, yeah, you're not going to get better. You'd have to go to an alternate universe. That was the passage that Natalie Angier, I'm sorry, Natalie Angier, she's a stark raving atheist, but she, in the New York Times article, said, all of these physicists involved in this have said, um, all of these, so many of these systems operate at the limits of physics. You would have to go to an alternate universe with alternate physical constants to be able to do any better. And so what Dr. Sanford perceived was like, look, biology is engineered, but it's ultimate engineering. And he was like, Sal, you have the right skill sets. We're gonna move into this area. And so around that time I also found out, actually before that I met Dr. Sanford, I found out that uh, at MIT there was an article released in November like 2002. So this is a while ago. This is even a while back, that 1/3 of the engineers at MIT work on biological problems. Now, it's not necessarily the full-time job doing biology stuff, but it's turning out biologists will have to consult engineers to help resolve to understand the biological problems, or to build the instruments to help, and set up experiments. So what I'm finding as I talk to research teams that try to elucidate, how the cell works, how the body works, how biological systems work, the primary skill set that is being recruited are chemists, biochemists, and physicists, computational scientists, and engineers. The last skill set that almost never appears are evolutionary biologists. I mean, that sounds so mean, but that's the way it is.
Well, Sal, to me, it's like taking your car to a mechanic, right? It's like you're going to take your car, you take your car to a mechanic and he says, well, I really don't know how it works, but I know I can fix it. I can definitely tell you where it came from. No, you want someone that's an evolution biologist. They don't know how it works, right? They really don't know how to fix it, but they know how it came about. I'm the
Yeah.
doctor, right? I know how it works. I know how to fix it. I'm not sure exactly how it came about. Okay. Uh, I was going to say that when you're mentioning the engineering, you may be interested in how Steve and I got together. So Steve Loftman is the co-author, and really, I had written about how the body worked at 5 or 6 different levels of teaching. Like, I even have it at a very elementary level and various levels. And then luckily, someone connected me with Casey Luskin at Discovery Institute back into 2014. I think he was just about leaving for his PhD at the time, and he connected with David Klinghoffer. So from 2015 to 2016, I just took all my material and I wrote about an 81 part series called The Design Body, about how going through all the systems, how they all work, how body controls water, how it controls the blood pressure and cardiac function. And some of these were like 4 or 5 articles at a time. Clotting, red blood cells, white immunotherapy, immunology. So about a year into that, or several months into that, Steve Loftman was reading it, and he connected with David Klinghoffer, and he connected with me. And the bottom line was, he says, Howard, you're writing about medicine, writing about physiology, but you don't realize you're writing about engineering too, right? He recognized the engineering in there. So when we got together and started, he says, we got to write a book, right? And we got together, and I learned a lot about engineering. He learned a heck of a lot about biology or physiology. And anyway, so initially when we started the book, um, probably my name would have been first and his second, because we hadn't figured out how we were going to fit the engineering in. All right. Around that time, also, they were coming up with the idea. The ERG was coming together, thinking about theory of biological design as well. So it ended up it may be the first book, first publication that actually talks about that theory. But by the time we finished, all I had simply done was provide, from my perspective, I just provided the data. Say, this is how it works, and then the engineers take it from there. They say, hey, yeah, this is where the engineering fits. And the two biggest things that I learned from Steve, the two things I argued with him about, didn't argue, but he kept mentioning to me, and this is what I'm involved with now. Because as a general practitioner, I was writing all this stuff, right? He kept saying to me, how does all this stuff stick together? How does it stay together? Like, what's keeping it all together, right? And that's what's called, I knew the answer to that was connective tissue, extracellular matrix, et cetera. But I told him, look, I've never written about that. And why would I? I mean, as a doctor, the only people usually involved in that are people who do wound care. Okay, maybe surgeons or wound care people, right? So that got me writing about that, which is what I'm writing about now. I'm studying that. And the second thing was, he says, well, how do you build this from the ground up? That's talking about development of the womb. I said, look, I'm not a neonatologist. I'm not an OB/GYN. I'm just a GP. And I came to realize that as a doctor, and I think this is the blind spot for biologists and physiologists, is uh, we don't have to make it. We just have to fix it if we can. So understand how it works and try to fix it. Like, as a doctor, trying to figure out what's going on with the patient, change this or that, whatever, maybe medication or not, stop doing certain things, etc. But we just assume Darwinists just assume that it came from nothing very easily. And I think, like you just said, Stuart Burgess's book on this one that's just come out, Ultimate Engineering, pretty well lays that to rest. Uh, and his credentials are just phenomenal too. So
Well, what is happening? Since we talked about ultimate engineering, and let me see, there is, oh my goodness, this is really a great chance we talk, for the longest time, evolutionary biologists were very upset. They said, why do engineers why is it, this is called the Salem hypothesis. They said it seems that the people who are most critical of evolutionary biology are engineers. And they're like saying these aren't biologists. And for a long time I was like, they do have a point. It's like I don't have any biology background. But that was like 20, 30 years ago. This is changing now. We are seeing the engineers, that mindset is very important now to being able to describe the operation and structure of biological systems. It's like, yeah, especially like systems biology. There's systems biology, and now we have biomimicry because biological systems have designs that are superior. Okay, I don't know that Emmanuel Todorov at University of Washington's an ID proponent. I'm just going to assume, forgive me, Dr. Todorov, if I misrepresent you, that he's like a lot of, secular researchers. It's like either he doesn't care or he thinks it's evolution. But he said, the human body, some people may say looks like it's sloppily designed, but that's not true. We're better designed than any robot. And so Stuart Burgess, who built robots and also built parts of space stations and spaceships and did just enormous amounts of things. He said all this stuff about like how the ankle is built and how, how the wrists and the arms and, evolutionary biologists said this is terrible design. He said, well, look, they're not engineers. None of them have published, none of them have designed anything, none of them have built anything, and yet they're going to say it's bad design. And he pointed out, look at all these papers. He said, to make some of these things, that is the perfect design. And he was describing things that they had been for the longest time saying are suboptimal. And so I'm this is just a plug for the book because you also gave as you said, you were involved, I guess, in the review of the book and also giving some pointers. So I'm going to just show, um, and I'll try to put this in the video description below after the recording is done, uh, where you can find this. But here it is, Ultimate Engineering. And it was released on Darwin's birthday just to kind of make a point that Darwin was wrong. And there's praise from all sorts of people, like a professor of bacteriology praising an engineering book. And there's another Royal College of Surgeons of England. By the way, do you know any of these gentlemen, like Nigel Jones or Alan Linton? Have you ever? Oh wow,
Oh, and Linton sounds familiar.
Stephen Palmer, Talbot Professor of Epidemiology. I mean, these are all medical doctors. David Galloway, Royal College of Physicians. Um, They have one engineer, professor of applied thermodynamics. Steve Loftman, your co-author, he's an engineer. Matti Laisola, who is a bioengineer. Casey Luskin, and there is somewhere here. I've got here, Mohammed Salim, trauma surgeon, and then Howard Glicksman, co-author of Your Design Body. Um, so I mean, this is great to celebrate because in me you have an engineer and you have a medical doctor, and then you know among our community we have more engineers, we have protein biologists, people from lots of people in the medical field. It's just exciting how we were all able to collaborate. And we actually do. We have a few evolutionary biologists. I think we're, who've kind of switched sides when they saw the light, like Jonathan McClatchy, and then a few people that we can't name. Um, so this is just kind of a glorious time. I mean, I look back to when, I was just getting that cup of water out there in the desert of, hardly any ID, and it was just the weekly wedge update, and then your articles and a few other things. So it's totally exploded. The culture, at least at the very high echelons, is changing. It's
Can I
exciting.
tell you what and it continues right now. In fact, I just spoke with Steve. I want to do some model. I don't know what modeling is, but I'm going to look it up and start investigating. But I want to tell you what what I was writing about. No, I don't think anyone else was writing it the way I was. I'm going to tell you that it's the seventh, I think it's the sixth or seventh article I wrote for the first series on our Access Research Network, which was exercise your wonder instead of exercise your faith, exercise your wonder. And it was the article on hemoglobin, which changed my thinking of how I wanted to write. So let's go to irreducible complexity. Okay. Everyone knows it's a error is a system of purposeful parts. Okay, you have to have all the right parts. They use Michael B. He talks about it in the Darwin's Black Box. He talks about the mousetrap, right? And there's five parts, and if anyone's missing, it doesn't work. Okay, and that's fine. But with what we're talking about is we're taking to the next level. Let's talk about the specifications of those parts. Just because if the hammer is isn't strong, if it's not made of solid iron, if the base is plastic instead of wood, so to what we call the material specifications and the functional capacity. If none of those, you can have five parts, but you're still going to be dead or it's not going to work if you don't have the parts working right. That's where the engineering is. What turned me on to that was I was writing the article about hemoglobin, went back to my physiology textbooks, etc. And something I don't remember ever knowing in medical school, but I actually found out I figured out, okay, how much oxygen the body actually uses at rest, 250 milliliters per minute. Okay. And I know the cardiac output, right? How much blood the heart pumps at rest, 5 liters per minute. And I knew how much oxygen each gram of hemoglobin can carry, right? And I realized there's a critical level. If the hemoglobin can only carry a certain amount, it carries a certain amount of oxygen, and you have a certain cardiac output, and you need 250 milliliters per minute of oxygen to be at rest, there must be a minimum amount of hemoglobin that you can be at rest. And that number turned out to be about 3.5 or 4 grams per deciliter. Okay. And I suddenly struck me. I thought, I've never seen a patient in my practice in all the years I've been practicing medicine with a hemoglobin less than 3.5 or 4. Right. And that's when suddenly I put it all together because you can have hemoglobin, but if you're not making the right amount, right? Because we know how much it carries, then suddenly that's when I started writing. I started actually putting the equations and the numbers into my writing, which you'll never see by an evolution biologist, right? And that's where I think Steve started seeing, you're writing like an engineer. I didn't realize, but I always loved math. I always loved numbers. I could have maybe been an engineer in retrospect. I'll tell you a joke. I grew up in a Jew. I remember John West asking me, "Why did you become a doctor?" I said, "Why did you become a doctor?" He said, "I'm Jewish. You're either a lawyer, an accountant, or a doctor." Right? I love numbers. Didn't want to be an accountant. Forget about being a lawyer. And so obviously I'm going to be a doctor. I didn't even know about engineering when I was younger. So anyway, but that's so I want to give you an example of what happened recently. There's a recent article I've had access. It's on science. What's it called? Science and Culture Today, right? It's about labor and delivery. All right. So I found an article in Science Daily was talking about how they finally figured out how the sensor works, the receptor in the uterine muscle to make labor and delivery. Like when the woman is in labor, what happens is they start going to labor, but as it continues to go on and the baby starts coming down, then and especially engages in the cervix, then the contractions become harder and harder and harder. Okay. And so I actually went back to the history and found out, yes, even at the time of Darwin, they knew this, but they weren't sure of the mechanism. Well, 60 or 70 years later, they figure out, oh, we got the hormones. Yes, progesterone keeps the uterus relaxed during pregnancy. And then as the progesterone effect starts to wane near labor, time for delivery, and oxytocin starts, it's like you got this two factors going on, like the push-pull principle in engineering. Oxytocin kicks in, and that causes the uterus to contract more. However, it still didn't explain why it accelerates so much at the end. Okay. So then they figured out because then the muscle actually starts to coordinate much better. And in the article I write saying you can have muscles, right? But if the muscle doesn't coordinate properly, if it doesn't contract, everyone contracting together, it's not going to function properly. And the example of that is the heart. You have the heart muscle, right? It's working fine. It pumps efficiently, right? But one of the commonest causes of sudden death is ventricular fibrillation. This is when the heart muscle is literally quivering because there's no coordinated contraction, right? You need to have that. That's what happens in the uterus at the end when labor comes on. they found out in in the 80s or 90s, there's these gap junctions between the muscles called connexin 43, and they there's more and more of them that develop as the uterus continues along labor and delivery. But they still didn't understand the mechanism. So then they found out these piezo 1 and piezo 2. The guy even won the Nobel Prize for Science and Physiology, I think in 2021. But in 2010, they describe how these work, right? They're like little propellers. And when there's increased strain on the receptor, it opens a pore that allows sodium, calcium to go in, and that's what causes that turns on, that signals these cells. And what it does, one of the main things it does is it increases these connexin 43 gap junctions within the muscles, right? And that's what makes the contraction better. So what I summarized at the end of that article was saying, well, what kind of thinking were these scientists using to figure this out? Were they thinking like Darwin, like, oh, it's just we don't know how this worked. It was just clunky type of mechanism. No, they already knew ahead of time. There's a receptor in there, there's a sensor that's somehow triggering this connexin 43. They had an idea about that. And when they finally got around to saying, when they figured out the piezo 1, piezo 2, then they said, well, let's see if there's any of them in the uterus or in the cervix. And they found them just recently. This is why that article was there. So if you look at that article, it actually what I described is that, like you're saying, systems biology, they're using reverse engineering. And the question becomes, if you're using reverse engineering to figure out how something works, are you thinking like a Darwinist? I don't think so. You're thinking like an ID person. How can you use reverse engineering and then say, well, it was an undirected process that caused it, but you're using reverse engineering to figure how something works. Just
Yeah, lest people think I'm exaggerating. Uh, uh, just go, I mean, just start taking some, I went to Dr. Sanford sent me off to the NIH to study graduate level biology. I was taking a cellular neuroscience course. My professor, so they had several professors teach it, each one in their specialty. And like one of the early professors in that series, he said, I had no biology background. I had a PhD in electrical engineering. I was hired on the spot. And I'm like, okay, that totally makes sense.
sure.
You're dealing with electricity. You're dealing okay, so like you have the hearing. A big part of electrical engineering for a long time and still even now, but before we got to the computerized VLSI circuits and all that, a lot of it was audio engineering, where you're taking sounds, amplifying it, and understanding the process. I mean, it's not trivial to be able to take a mechanical device and transduce that into an electrical signal. That is not trivial. It is
No.
also not trivial to be able to recognize sounds. Anyone who's involved in voice recognition and automatic, speech, this is just like a nightmarish task. I remember when I was an undergrad in electrical engineering, I was asking around. I said, "How hard is it to do speech recognition?" They said that's going to be really, really hard. And we have these gigantic server farms that try to just do exactly, voice recording and then speech recognition. And, now it's gotten to the truly the state of art. But they hired him on the spot because they needed someone to help understand how the ear works. And I'm just like, look, this is just you're taking sonic waves and transducing it into electrical signals. It has to be recorded. The idea of being able, we take it for granted we could recognize a voice or a familiar tune. To actually build a system that can do that, it is just unimaginably difficult. We take for granted, we just seem to think is just so natural because it's so effortless. The amount of machinery required to implement that is staggering. And they needed an engineer. They said he has the right skill set. He understands things like Fourier transforms and all of the things we do in engineering because as you're taking the stages from like a physical signal into electrical and all the processing, there's so much stages of mathematics involved to build the machinery to understand and we're still only grasping a small part. But I mean, you think about how is that you can remember a familiar voice. I mean, this is a very non-trivial problem because I was involved in automatic target recognition, being able to recognize even objects and sounds. This is just like not trivial. And so this is what is happening now is this is the right skill set that is needed to understand how biological systems work. And I'm just going to just show this here. If you see me looking kind of occasionally, as the audience will see me just turning my head as you're talking, it's because sometimes I'm desperately trying to Google and find a diagram that I could show. But this basic diagram, so the electrical engineers out there will recognize that this looks like a circuit diagram, but this describes in abstract how a nerve cell works in some of the ion channels. They're probably way better diagrams than this one, but I just wanted to share that. So it's really nice that um, medical doctors are talking to engineers, but it's in my view, we're all starting to become engineers because the body is designed. It's the right skill set. Everyone just has their specialty. And the body is so complex. It's just, we're, as it says in the Psalms, we're fearfully and wonderfully made. It's just incredible what the human body can do. So, um, I'm going to pause the recording, just briefly. Hang on. Okay, so we're unpaused now, and I had to pause to bring up a PowerPoint slide I wanted to share, but Dr. Glicksman wanted to talk about impedance matching, which is definitely a electrical engineering uh, concept. So please share, and I think this is in regard to our auditory system.
Right, you were just talking about the auditory, so I just wanted to bring up that for the audience, and if you could maybe you have notes after, but we have Steve and I we did, and with Cal Covert we have three videos, right, through the Discovery Institute on human, what is it? Secrets of the Human Body, right? If or it's on the Discovery Institute, and we have three of them. And the second one is living in a three-dimensional world. And in there we talk about vision, but we also talk about hearing. And we show so that give you an idea. So the key thing, what you're talking about, basically, the neuron is the hair cell in the cochlea after after the wave comes through, they get stimulated. So that yes, that's important. But even before that, you've got the problem with the air coming down, the sound waves coming down the ear canal, hitting the eardrum, and of course that's air. But now that message that power has to be passed through to the cochlea, which has water in it. So you have this impedance matching, which Steve Laughlin picked up right away. Initially, I had written about it, but when we actually got to the book, he wrote about it. He did a much better job. Now he's an engineer, and same thing with the division. But anyway, that part of it is just as important. There's so much engineering in the air, especially he loves the ossicles, the three bows, the hammer, the anvil, and the stirrup, right? And they are perfectly matched to do the job, right? To pass that energy on. So he also, I also learned from him that I didn't know is that they're the only bones that when you're born that they don't grow. They're the same size at birth
Hmm.
for your whole life. So. Um, Anyway, we have our other book, Your Amazing Body. We had Your Design Body, which is about 400 pages, but then a scaled down version is Your Amazing Body with those videos. And we got one that's a great one on making a baby that's out there really right now. So if you want that will sort of get them into some of the stuff we've been writing about.
Well, while we were on pause for the audience, I kind of recruited Dr. Glicksman to come on again, and I'm sorry if I was presumptuous, but this is such good material. I do want to point out how this relates to some of my work. Um, I had definitely seen the engineering, but the difficulty was being able to deal with the evolutionary biologists who say, well, this just evolved by natural selection. And for those who are familiar with mathematics, and sometimes we might have an intuitive idea of a mathematical theorem, but actually coming around and formalizing the argument is sometimes agonizing. I happen to have tracked for example, like the fundamental theorem of calculus. We actually had the fundamental theorem used for like maybe a couple hundred years. I don't have the exact figures, before we actually came up with a proof that it actually was true. So we're actually using an idea that wasn't formally proven. Everyone pretty much assumed it was correct, but it took, Riemann in the 19th century to codify it to the level of satisfaction for most people. And for me, when I'd seen all these systems, I'm just like, well, uh, you get the sense it was intelligently designed. But you know, if Darwinism and random mutation and so-called natural selection, which is a misnomer, is able to do this, um, then it kind of weakens the idea of the need for an intelligent designer. And it's actually taken a number of years to actually codify the level of proof. And now we also have a lot of physical experimental evidence. So I'll go with the experimental evidence first. It turns out Darwinian processes, which we mislabel as natural selection, I prefer to call it brain dead stupid Darwinian processes because I think that's more accurate. It actually, over time, the inclination to improve reproductive efficiency actually causes populations to lose capability. Um, this is not hard to see that, like a hiker who is equipped with lots of winter gear, and it just happens to be a really warm, like an Indian summer or a particularly unusually warm day, and like, hey, I can move faster. Why don't I dump all my winter gear? And sure, they can climb the mountain faster. Well, this happens also kind of by way of analogy in biology that if stuff is not immediately needed, there's a tendency to, because of the drive to increase reproductive copying efficiency, it will often dump genes and stuff it doesn't immediately need. And now it becomes very maladapted to other environments. This is now even in the literature, this is called loss of versatility. And this has been staring us in the face for decades, but no one really wanted to admit it until recently in a book, uh, Evolutionary Cell Biology by Michael Lynch. Lynch said natural selection is expected to favor simplicity over complexity, which is the exact opposite of what Darwin claimed. Darwin claimed his process would favor complexity, and it was through by means of natural selection, organs of extreme perfection and complication were evolved. So so we can argue using Michael Behe's irreducible complexity, or what I call all or nothing complexity. But now even the evolutionary biologist using population genetics, and then in the era of cheap genome sequencing, we're actually able to know that genes are lost. We didn't know that as well as we do now because genome sequencing is now anywhere from 1 million to a billion times cheaper than it was 20 to 40 years ago. What that means now, for $1,000, we can do what would cost $1 billion to $1 trillion back in the day. We actually now know that Darwinian, brain dead, stupid, unthinking Darwinian processes destroy. It cannot be used. And this is quietly matriculating through the upper echelons of evolutionary biology, but it doesn't get a lot of press. And so we have this cultural momentum I still see in people defending evolution, even evolutionary biologists still promoting Darwinism, and I'll get in their face. I'll say, "Well, look, you're a little behind on the latest literature because look at all these findings." There is a experiment by Richard Lenski. Um, he is one of the co-authors. The title is "Genomes Decay Despite Sustained Fitness Gains." There are now articles that say selection-driven gene loss. And I'm like, look, this is actually more ubiquitous than you're wanting to admit. This is the normal mode because, according to Lynch's axiom, selection is natural selection, Darwinian process is expected to favor simplicity over complexity. Recently, Masatoshi Nei, who's a very senior evolutionary biologist, I used his software in graduate school to submit my assignments in bioinformatics when I was studying under a top evolutionary biologist. Masatoshi Nei, who's in the National Academy of Sciences, said Darwin never proved his claims. And that's shocking. And I'm just like, look, it's in all the textbooks, and you're saying now that he never proved his claims. It's like, yeah, under in the top echelons of evolutionary biology, they know he didn't, but they don't want to really broadcast that because, well, it's kind of bad for business. So I just had to share that. And so what had happened, this has been a transformation for me. I was not yet at the stage that I could really appreciate all the stuff that's coming out now because the evolutionists will say that's just an argument from incredulity. And what I needed to add to that is, for one, well, at the very least, then you still haven't proven your theory. You can't just say because we don't know it, therefore Darwinism did it. That's illegitimate. So at the very least, as Masatoshi Nei had pointed out, you can't claim Darwinian evolution could evolve this. Now, the alternate mechanisms are just as bad that he suggests and other evolutionists have suggested. That's a story for another day. But the other thing is now it's not an argument from incredulity. We have experimental evidence that shows that it's wrong because genome, we're seeing that Darwinian processes wreck the genome. I mean, this is now experiment. It's like, no, this is not an argument from incredulity. We know that it's wrong. We may not have, yeah, we might consider that if we'd seen God actually, like in the Old Testament, he would actually appear in a burning bush or whatever, then yeah, a lot of us would be believers. But I'm pointing out that uh, uh, someone actually, I can't take credit for this. Dr. Orion Taraban said, look, you can't really prove that the self exists, but it really makes a lot of operational sense to accept that you exist, um, even if you can't formally prove it. And I'd be kind of the same for intelligent design. He said this is actually an argument from God, an argument for God that look, if you can't necessarily formally prove it, but it seems to make the most sense, why don't you just assume it is true? Because it seems to work better. And there's actually been the Discovery Institute released a video a few years ago. It was so funny. They said there are actually people that argue that consciousness and the self doesn't exist. I'm just like, okay. So
Yeah.
Um, I know that we're gonna be a little abrupt in closing this. I was desperately trying to show this thing about the extracellular matrix that relates to collagen, and we're just gonna have to cover it next time. By the way, this is the amino acid sequence of collagen.
Oh, I remember this now. Yes.
Yes, and this is the amino acid sequence of the zinc finger protein. Uh, the reason I showed these two is it's very clear, even to evolutionary biologists, these have no common ancestor. They just kind of into place. And maybe that's the subject of another talk. I really um, am eager, if we're able to talk again, I'd like to hear more of your adventures as a general practitioner and as a hospice care physician. You're definitely my hero. You've saved so many lives of people out of hospice care that were sent home to die, and God has used you to work miracles and bring people literally back from the dead. And I know that from personal experience. My mother was under hospice care. She had a full recovery, and I praise God for that. When she recovered, those were some of the happiest years of my life. She eventually went home to be with the Lord. So I really just wanted to express my personal thanks for your work and the influence you've had on people's lives. In addition to your intelligent design work, you're one of my heroes, Dr. Glicksman.
Well, I don't know what to say, Sal. I mean, I'm just really impressed with your talent and everything you're doing. And and at some level, we're at the two extremes. You're at the molecular, genetic level, and I'm sort of the macro, the multicellular organism level of how the big systems work. But it all comes together. So it's been a great honor to be here to talk to you. And a lot of the stuff I didn't know about your past. So it's great to, as I was telling you that when I was writing those articles in the old days, I used to say, as long as it helps somebody, Uh,
Well, you've made me aware of more of the materials, and rather than, uh, reinventing the wheel, I might look through that and then maybe share it with my audience here. But then I might have to ask you to come on and just elaborate more on some of the stuff in the videos. I think that'd be really fun. Um, so, uh, God
Sure,
willing, until we
anytime.
meet again, do you have, I'll give you the last word. You're the guest to honor here. So if you have any closing thoughts.
Uh, all I can say is that doing this, writing this stuff has really brought me closer to the Lord. I mean, imagine, when you're writing about your stuff, right? I'm writing about how these systems work. This last article that I wrote of how how a woman has labor and delivery, all the things that have to be right to work properly, and it just puts you on your knees. You just can't help it. Like, Lord, you are just so awesome. And like you said, Psalm 139, 13, 14, we're incredibly made. And so it's been a joy talking to you, but it's a joy continuing to be able to do this. I think both of us feel that we're where the Lord wants us to be and doing what He wants us to do. And there's nothing more satisfying than that in all of life.
Well, I'm sorry, I'm going to have to take back my word. I think I want to have the last word here because I do know some of the people out there, they hear all this and they're going through a lot of suffering. I mean, there's a lot of tragedy in the world. And the number one thing that I found when I talk to people, it's like, why do they reject the idea of a creator and intelligent design? They say, well, look at all the problems. How could a God allow this world to be such a mess? And simply put, just food for thought, and I've elaborated on this in other segments, but a lot of people don't know that the fairy tale Snow White drew upon a lot of Christian themes. So the story of Snow White is and I read this to my Bible study because this is specifically why I covered it to help people kind of navigate, if God created life, why did he allow death? So now look at the story of Snow White. So Snow White is this beautiful lady, and um, her real mother died. The evil queen stepmother, she got an evil queen stepmother to marry Snow White's dad. And the evil queen stepmother was so jealous of Snow White's beauty, she wanted to kill Snow White. And the evil queen stepmother succeeded in killing Snow White, but then the prince comes along and miraculously she's resurrected from the dead. The evil queen stepmother's destroyed, and Snow White and the prince live happily ever after. Anyone familiar with Christian theology totally sees this. And I asked my Bible study, I said, well, what would the story be as beautiful and meaningful? Would the happy ending be as meaningful if there were no evil queen, if there were no death? Because of death, there is the possibility of resurrection. And they said, yeah, it totally makes sense now. I said, this is Second Corinthians chapter 4, verse 17 in the New Testament in the Bible. For this momentary light affliction is building for us an eternal weight of glory. So even the pains that we suffer today can't have meaning if there is a resurrection at the end of time. And so that's why we've put our faith and trust in Jesus Christ, our Lord and Savior. And this is what this show is all about. So, Dr. Glicksman, thank you for joining us. Thank you,
Thanks,
all the
Al.
audience. Take care, and God bless you all.